For Unit 10, Day 7, I'm splitting this up over two videos. We're talking about two things today that are pretty much related, but I want to make sure I have two videos to kind of separate the ideas into your minds. The first thing is the law of sines. So this here is a setup for the law of sines. It's the formula that we're going to use. And sometimes with the law of sines formula, it's actually written this way with sine A over A equals sine B over B equals sine C over C. It really doesn't make a difference because it's a proportion and we're going to cross multiply anyway. You just have to make sure you're consistent. If you have the sides on the top, on the left, they have to be on the top on the right. So in this particular case, it's really important at first to make sure that we all know what we're talking about. And in a triangle, the vertices, or the angles, if you want to look at it as the parts inside, are all labeled by capital letters. The lowercase a, b, and c represent the sides across from those angles. So in other words, if this is angle A, side A is here. Angle B has side B, and angle C has side C. So you've got to make sure in your mind you're distinguishing a relationship between the angle and the side across from it. So for question number 1, it talks about a surveyor that needs to define the distance between 2 points A and B. And those 2 points lie on the opposite bank of a river. So a point C is chosen that's 160 meters away from point A, but on the same side as the river is point A. So that distance from A to C we definitely know is 160. It gives us the angle measures. If we're standing either at point A or at point C, the angle measure away from that 160, if you were to envision where a line would go from points A and C over to B. So they give us those angle measures. They want us to find the distance from A to B to the nearest meter. So they're asking for us to find this measurement here. In order to use the law of sines to find, and here's its job, to find a missing angle measure or side length, you have to, in your picture, have a side across from an angle and be using both of those twice. Now, when you look at this, you may say, well, this can't be law of sines then, because this 160 that's here has an angle across from it, but we don't know that angle. But remember, all the angles in a triangle add up to 180. So in this case, if I add the 41 and the 55, I get 96. And then for this, if I do 180 minus the 96, I end up with 84 degrees right there. So that angle in there is 84 degrees. So my setup is an 84-degree angle with a side across from it. So in this case, I am not doing anything with angle A or side A. I'm only dealing with B and C. So for the formula, I'm picking the two that I'm working with. So I'm working with B over sine B is equal to C over sine C. And I'm going to substitute in what I know. And when I substitute in everything I know, I have a B value of 160 over the sine of angle B, which is 84, equals the C side that we're looking for over the sine of angle C, which is 55. And at this point, I'm going to cross multiply and solve. So when I cross multiply, I get x times the sine of 84 equals 160 times the sine of 55. Remember, I'm solving for x in this case, so I want to go through and divide by sine 84. And then I'm going to type that into my calculator, and I get that x is 131.786266. Final answer rounded to the nearest meter, 132. The reason why we have to use law of sines or law of cosines, which we'll talk about in the second video, is because these triangles do not have a right angle. And the SOHCAHTOA that you've been using right along now is only for when you have triangles that have right angles in them. For question number 2, it's a little bit different. In question 2, they're asking for us to find the sine of angle B. So I'm going to draw my picture. I've got triangle ABC. A is 30. Side A is 12. That's convenient. I have an angle and a side across from each other. Side B is 10. And I'm looking for information about the sine of B. So when I set up my equation now, I'm going to use A over sine A, because that's a side and an angle across from each other that I know, equals B over sine B. Plug in what I know, 12 over sine 30 equals 10 over sine of B. Remember, this problem is asking for me to find the sine of B, so as soon as I get sine B alone, I'm done. Cross multiply. Divide. And when I go through and divide, I'm going to get a decimal, but if I have my calculator convert it back to a fraction, I end up that the sine of B is 5 over 12, and I just leave my answer like that. They wanted sine B, I found sine B. So the question is finished. In question number 3, it's a word problem. These are extremely typical. It's actually called a double triangle problem because you can see you've got two triangles next to each other that when you put them together make one big triangle. This side right here is called the shared side, and it's very common in these double triangle problems to have to find out how big the shared side is first. So when I go through and I take a look at the information that's here, it's talking about a car moving towards a tunnel, and the top of the hill, which they've labeled H, is sighted from two locations, A and B. And the distance between A and B is 250. When they say that it's sighted, it means that they found these angle measures measuring from A and B back up to the top of the hill. So they've got somebody standing at points A and B, looking up at the top of the hill, what was their angle of elevation. So in this particular case, we are asked to find the height, which is over here. I am not going to start by working with the height, though, because I don't have enough information in the triangle on the right-hand side to do that. I am, however, going to start with the triangle that goes from A to B to H that has a 30-degree angle, a side of 250. The shared side that I'm looking for, remember the rule here, find the shared side first. And you may feel like you don't have enough information. Granted, we have this angle and this side, and then we have this side, which means we probably need to find this angle. And at first glance, you may think you don't have enough information to find that angle, but you really do. Remember, over here, these two angles are supplementary, so this is 135. And then this triangle has to have angles that add to 180, which means I'm going to have 15 degrees right here. So over here, I can put that 15 degrees, and then I end up having the perfect setup that I need to go through and do law of sines. So I'm going to set up my law of sines now. I'm going to do H over the sine of H equals A over the sine of A. My H, 250 over the sine of H, so sine of 15, equals sine A, which is Y, over sine A, or sine, A, which is 30. And then I'm going to cross multiply and solve. When I cross multiply, I get 250 sine 30 divided by sine 15. And I find out that my shared side is 482.9629131. That was, keep in mind, just the shared side. So in here, this shared side of Y is what we have right here. Remember, it's this number. So now if I focus on the triangle that I have that has 45 degrees here, H here, and that side of Y, which is 482.9629131, if you're like me, you're getting sick of writing all those decimals out. So now that we're here in a right triangle, I can use SOHCAHTOA trig. So I'm going to go back now, and I'm going to do the sine of 45 equals opposite over the hypotenuse 482.9629131. Cross multiply and solve, and I get H is equal to 341.506, 3509, and they want that height to the nearest foot So 342 for my final answer for the height of that. Make sure you watch the second video, which is on law of cosines for this day.